So get this, the Earth acquires 40,000 tons of mass every single year. More and more people are being born, new buildings and structures. You might think that's something that adds mass, but nope, since it's created out of existing matter on the Earth, it's actually dust falling from space to our planet. That dust consists of vestiges coming from our solar system, like space bodies that never managed to form into a planet, or asteroids and meteors that fell apart on their way and now drifting around. Our planet is there like a giant vacuum cleaner that pulls in all those particles of dust powered by gravity. So yes, Earth gains weight, but some calculations also say the entire planet, including the atmosphere and the sea, is losing around 50,000 metric tons of its mass annually. Gases like hydrogen and helium are within our planet's atmosphere, but they're so light gravity can't retain them there. So huge amounts of those gases escape our planet every year. 6 pounds of hydrogen every second. Sounds like a lot, but the Earth is really heavy, so it would take trillions of years for all the hydrogen to escape our atmosphere. Also, the planet's core is like some sort of big nuclear reactor. It runs all the time, so it gradually loses energy, which means it's losing mass too. Our planet is not a perfectly shaped sphere, it's more like a squashed one. As it spins, gravity is directed toward the Earth's center, while a centrifugal force goes outward. Earth has a tilted axis, so centrifugal force doesn't exactly oppose gravity. Also, gravity pushes those extra masses of Earth and water up at the equator into a bulge. Earth also has a waistline, 24,900 miles. You weigh more standing at one of the poles than at the equator. Although, for weight loss, Pluto comes as the best option. A 150-pound person would weigh around 10 pounds there. Avoid Jupiter, the same person would weigh over 350 pounds there. Our planet is all green and blue now, but chances are it used to be purple. Scientists think ancient microbes might have used some other molecule to harness the sunlight instead of chlorophyll that gives plants their green color. That molecule possibly colored the living organisms into a more violet shade. The Earth is electric. Just one stroke of lightning can heat the air to over 50,000 degrees Fahrenheit, which causes the air to rapidly expand. That same ballooning air makes a shock wave we know as thunder. 6,000 lightning flashes appear all over the planet every minute, and the longest one occurred in the sky above Brazil, 440 miles long. Newer studies found out that the Earth's core is as hot as the Sun's surface, over 9,300 degrees. The driest spot we have is the Atacama Desert of Peru and Chile. The center of Atacama has spots where we've never recorded any rain. The coldest place is naturally Antarctica, where winter temperatures can go down to minus 100 degrees Fahrenheit. No thanks. It's also the biggest desert we have on Earth. We imagine deserts as endless, sandy, and insanely hot areas, but there are coastal, subtropical, and polar deserts. They all have wind-swept and barren lands, which makes them very difficult for animals and plants to inhabit. The Pacific Ocean is the Earth's biggest ocean basin, which covers a huge area of almost 80 million square miles. The Pacific contains over half of the free water on our planet, and is so big all of our continents could fit there. Earth used to have 2 moons, or at least that's something scientists believe. That second one was almost 3 times smaller than the one we have today, and may have orbited our planet before it slammed into the bigger one. This clash may be an explanation of why the 2 sides of the moon we're left with is not equal. And there are moonquakes going on. It looks pretty inactive from our perspective, but the ground there is definitely shaking, although less than on Earth. Moonquakes shake at great depths, especially midway between the lunar center and its surface. To get to the longest mountain chain, we have to look way down under the surface of the Atlantic Ocean. It's a chain of volcanoes that goes about 18,000 feet above the bottom and spans over 40,000 miles. We have a magnificent planet, more than 4.5 billion years old, which makes it 10,000 times older than humans. But it's not the same as it was in the beginning. The ground we walk on is recycled. Earth has its cycle. Magma from the depths of our planet comes up and hardens into rocky matter. Tectonic movements brings the rock to the surface, where erosion happens. That's a process where wind, water, and other natural forces break apart rock and changes it. The small pieces get buried, deposited, and compacted into sedimentary rocks like sandstone. If these rocks are buried deep enough, they get cooked and transformed into magma, so the whole cycle repeats all over again. We got used to seeing lava and ash coming out of volcanoes, but some of them even produce their own flashes of lightning. In 2020, the Taal volcano, which is around 40 miles away from the Philippines' capital, Manila, started blasting smoke and ash pretty high into the air. Inside its ash column, small pieces were colliding and then producing lightning flashes people could see scattering across the sky. Lakes can go crazy and explode too. Nios, Manoon, and Kivu are 3 lakes that sit above volcanoes. Since there's magma under their surface, there's carbon dioxide released into the lakes, which leads to a deep gas layer above the lake bed. It's pretty rare, but carbon dioxide can suddenly erupt from the lake and form an unpleasant gas cloud, similar to something a volcano does. 70% of our planet's surface is covered in oceans, but we've only explored 5% of them. And around 300 million years ago, I wasn't around then, we only had one massive supercontinent called Pangaea, with one huge sea, Panthalassa. Surprisingly, coral reefs are the biggest living structures. They consist of small coral polyps, but together they make a true community of organisms and a very important part of Earth's ecosystem. Some coral structures can even be seen from space. The Earth's surface is not evenly shaped, which means mass is uneven too. That way, gravity is not the same in all spots on Earth. There's a mysterious anomaly in the Hudson Bay of Canada. The gravity there is lower than in other regions surrounding this area, and scientists believe it's because of melted glaciers. During the last ice age, that region was covered in ice, which is now long gone and melted. But the planet hasn't completely recovered from the icy burden. Gravity over any area is proportional to its mass. The glacier left an imprint that pushed aside a part of the planet's mass, which is one of the reasons why the gravity is weaker in that area. Some bugs get nastier when in space, without gravity. Studies showed some bacteria, like Salmonella, can make worse damage in space because there's something in the lack of gravity that makes them tougher and changes their activity. The days on Earth are slowly getting longer. When the planet was formed, days were about 6 hours long and gradually got longer. 620 million years ago, a day lasted 22 hours. Today, we have 24 hours, but it's increasing by around 1.7 milliseconds every century. This happens because of the Moon. It's slowing down our planet's rotation with the tides it helps create. When the Earth is spinning, tidal ocean bulges are pulled a little bit ahead of the Moon-Earth axis. That makes some sort of force that slows down the rotation of our planet, which is how our days are getting longer, but really slowly. We'll have to stick to our 24-hour schedule for a very, very long time. Earth's core certainly seems to be far away from us, but the distance is not that big, 1,800 miles. That's shorter than Route 66. The strongest earthquake we ever had was in Chile, a magnitude 9.5. If an earthquake ever reached magnitude 12, it could split our planet in half. Also, if there's an earthquake happening, it can hit more than 400 miles under the surface, which is why people on the other side of the planet can literally feel that. Our planet has around 100 million times more individual viruses than there are stars in the universe. Clouds are not some fluffy things whose shapes we sometimes like to watch. They actually help regulate the temperature of Earth. If we could pull out all water droplets in clouds and bring them to the surface, that would cover the planet with a liquid film as thick as a human hair. And yet, such a small amount of water brings enough differences with the weather and climate. Our planet would be 13 degrees hotter if it weren't for clouds.